Hi class, this is Professor Shepard. Let me take you to the slide that we stopped at. Here we go. ICAPM, which is International CAPM. We're just assuming that markets are global and not domestic. And this is the formula. It's the same thing. It just says global up here. Everything is global. So not a real change in your numbers. I think the important thing to recognize here is a couple of these comments are not really correct. Risk-free rate is unlikely to change. Well, that's kind of hard to say because I know that the Swiss franc bonds, there are some of them that have negative yields right now, so they wouldn't have known this because this slide must have been put together before the market crash, even though this says 2016. Sometimes things don't get updated, and that's life. But beta could easily change. So let's just accept the fact that we know that risk-free rates, especially if you're working on a global investment, could change. Okay. So let's look at this example. Here, domestic portfolio for Swiss investors. Now, just take a look. You see 3.3 bond index, 3.3 bond index. So that index could be 3.3 or it could be 0.1. Okay, it really depends. Right now, it's very low. But the Swiss market portfolio, and that is in Swiss francs, it could be at 10.2. It's okay. And the Financial Times Global Index in Swiss francs, that's an international index, could be returning 13.7. Okay, which means that since these two indexes have different returns, the beta will have a different return. Because remember, we looked at the calculation of beta, and it really depended on the return of the security versus the return of the market. A very interesting calculation. I'm not going to go all the way back in the slides and show you how beta is calculated, but it really depends on the two market returns. You can also notice that it doesn't make a big difference. Here we have 9.40, and here we have, if you were a rounder, you'd say 9.40, but you'd be wrong. It's 9.384. And if you're doing work for me on my calculations, I always want you to carry things out 2 decimal points. Anyway, let's go take a peek at the next slide here. Very important slide. Weighted average, I'm going to read it. Weighted average cost of capital is normally used as the risk-adjusted discount rate whenever a firm's new projects are in, and here's the key point, the same general risk class as existing projects. On the other hand, a project-specific required rate of return would be used if it was a project that was different. So let's make up something. You have a company, you make shoes. You decide to expand because one of the new people that joined your firm is an expert in computer chips, and you expand into computer chips. Well, if you're going to discount that cash flow of this business to analyze whether you should buy it or not, you're not going to use your weighted average cost of capital. You're going to have to figure out another rate to discount by. You will adjust your weighted average cost of capital. There are a few ways to do this. Well, you could find a firm just like the one you're going to buy. That's called the pure play approach. And you could figure out what their beta was and calculate their cost of capital and use that to do your discount. You could hire experts to help you figure out. That's if you couldn't find a pure play, and the reason that you might not be able to is it's very difficult to find a pure play. You might hire experts to help you figure out what the discount rate should be, or you may say, I'm an expert in business and in finance. I went to CUNY, SPS. I can figure out what to add to this. I'm going to add 3%. and so my cost of capital will be 3% higher when I discount this. Really depends, but that's where it's not a science anymore. It's an art. Let's take a look at the next slide. Okay, so in practice, calculating a firm's cost of equity premium is controversial. So we have another controversy here. CAPM is widely accepted. However, I did tell you that there's also something called the Farmer-French three-factor model that you must learn. It will be on your test, probably an essay question. Okay, so you better watch that video. So there's a discussion about what the market risk premium is. So what is the market risk premium? Just so you know, there it is there. It's the market return. That's a risk-free rate. Some people believe that you should be forward-looking when you're trying to figure out what the projection should be. Other people say, look, well, we're going to go back. We're going to look at returns over a historical period, and then we're going to come up with what the market return is. Well, I probably side with the historical period because I know I can't figure out what the market return is going to be. If I could, that would be great, but I can't do that. Then there's an issue about arithmetic versus geometric average returns. The numbers that are used and the authors use in this book are geometric, and I agree with that. It's just different analysts and different academics tend to use different measures for market risk premium. And so let's just go to slide 13.4 and take a look at it. Wow, a big difference. Look at the differentials here. Here the risk premium is 8.8. Here the risk premium is 5. Market return, well, since you know that they're using a risk-free rate of 4, this means that the market return here has to be 12.8. Right? Let's see. 4 plus 8.8. Yeah. Right. So that's a big difference. Yep. It's a big number, and that's a big differential. And the beta here is, we're using a beta of 1, so not a big deal here. And then we're adding 4 again, which gets you to 12.8. But take a look at these numbers. There's a big difference. My view is that the market return is somewhere between 6 and 8.5%, and that's based on research that I've read and people that I've talked with that have done research on it. So just so you know, there is a discussion about this. I think it makes sense to stop here. It looks like we might even go to 5 slides on 5 PowerPoint slides on this, but I don't want to jump into something new. So I will be back.